Hi, welcome everyone. In this video, we are going to be graphing rational functions. If you notice, the degree of our numerator is 1 because its largest exponent's a 1. The degree of the denominator is 2 because the largest exponent's a 2. Since the degree of the numerator is smaller than the degree of the denominator, that means that my x-axis, the line y equals 0, is going to be a horizontal asymptote. So, horizontal asymptote, I'm abbreviating, is the line y equals 0, your x-axis. So, let me put that on there. Okay. Now, let's see if we have any vertical asymptotes. If we have vertical asymptotes, those would be called points of discontinuity. Why? Because it makes the function where it's not continuous. What does continuous mean? It means that I could draw the whole thing without picking up my pencil. However, because we have x's in the denominator, we are going to have points of discontinuity. All right, now, here's the key. These are either removable or not removable. What's the difference? Removable means there's a hole. That means part of the denominator cancels out with the numerator. All right. Not removable means part of it does not cancel out. None of it cancels. So we're going to factor the denominator. So we recopy our numerator, x plus 6, factor the denominator. So we're going to have an x and an x. The last number's negative, so that means one's a positive and one's a negative. Because we have to have numbers that multiply to give you -6. But when you add them together, you get a positive 1. So that means 3 and -2. And we find our vertical asymptotes by taking our denominator and setting them equal to 0 and solve for x. So x plus 3 equals 0. Subtract 3. X equals -3. And x plus 2, that's not a plus, it's a minus. Let me fix that. X minus 2 equals 0. So we add 2. That's what happens when you get a little rushed. So try not to rush. Okay, we have x equals 2. So those are my vertical asymptotes. So I'm going to go to -3, and I'm going to put in my vertical asymptote. I like to use little dashes or little dots for my asymptotes. Reminds me those are lines I don't cross. They're not technically part of the graph, but it shows me what is missing, what is taken out. Okay, in other words, those points of discontinuity. That's the math terms for it. Okay, and I didn't put any black lines down here. So let me fix that. Okay, all fixed. Now, let's make a table. What I want to do is I want to choose numbers that are to the left of this -3, between -3 and 2, and to the right of 2. All right? There's no set formula for how many numbers you have to pick. Just pick as many as you need to be able to see the shape of the graph. Okay? So, if I were to plug in, -4, I'm going to get 1/3, 1/3. So the point -4, 1/3 is only up less than half right there. Okay, now it's going to hug close to this, so let me get something in between there. How about negative 3.5? Now, when I plug that into my calculator, I get 0.9. Now, it's up a little more, but it's not up a whole lot. But you can still see it's going to curve up. Remember, it doesn't cross the asymptote, so you know it rides right along the asymptote, and it curves up, riding right along that asymptote. Okay? Now let's see what happens in between. So if I were to plug in negative 2 for x, I'm going to get negative 1 for y. So negative 2, negative 1 is right there. Okay? And then plugging in negative 1, I get negative 0.8. So that's almost down to negative 1, right about there. See, up just a little bit. Okay, and let's plug in 0. If I plug in 0, I'm going to get negative 1. Okay, so right there. And let's plug in positive 1. Might as well. Let's get a lot of numbers on here. And I'm going to get negative 1.8. See, negative 1.8 is almost to here. Right about there. So what this is going to do is this is going to hug the asymptote. It's going to curve and then curve right back down, hugging that asymptote. It's like an upside down parabola, okay? It kind of flattens out a little bit at the top, but it's not much. All right, now let's take a look at to the right of our 2. So let's try 3. If I tried 3, plug that in, I get 1.5. So at 3, I'm up to 1.5. Right there. Now I plug in 4 as well. So let's do that. And we get 0.7 when we plug that into our calculator. So at 4, you notice it's going down. Right about there. So, rides right along the asymptote. Curves down. There we have it. So, curve, curve, curve. Wow. And these rational graphs, they're pretty fun. I hope you enjoy it. Bye-bye.